Okay, we're on. We're going. I've decided to lose the gum this time. That's pretty distracting on that last video. You might be saying, well, why'd you pick up smoking? Well, or maybe you think this is a piece of chalk. It's neither. I'll show you what this is. You see what this is? This is a magnetic stirrer. I can put this inside of a beaker, and it'll spin around in there and stir. And that's what I'm going to use it for. I'm getting out of the picture here a little bit. It's hard to get all of us in here, me and Mary and stuff. But anyway, this demonstration, I've got Mary because this is called Mom to the Rescue, this demonstration. But the mom in this case is milk and magnesia. Get it? Mom, milk and magnesia. Okay, and of course Mary is our mother too, so I've got her with us here today. Anyway, let's get started. I've got a beaker with some ice in it, and I'm gonna put some water in it. Okay, that's pretty good. And I'm gonna put the stirrer in it. Okay, there we go. Now, I think I will put some, well, let me get it stirring. There it goes. Okay, I don't know if you can see or not, but it's stirring around in there, the little magnetic stir. And I'm going to add some milk and magnesia to that. There we go. That's probably enough. That's pretty white there. That's the milk and magnesia. Okay, so now we're stirring that up, and we're going to use an indicator today called universal indicator. Okay, it's kind of like liquid pH paper. Let me put some in. There we go. And now you see we got a nice kind of rich purple color. Well, that rich purple color is because it's basic. The magnesium hydroxide is basic, and that's the purple color of a base there. The universal indicator is giving that. Now I need to get some acid. Oh, I forgot my acid. Let me grab it. Here, I've got the acid. It's the acid, the hydrochloric acid from the demonstration that I did with water into wine. Okay, so here we go. Ooh, look at that. There is. It changed very quickly. Okay, so at red, that was the color of the acid. And then the magnesium hydroxide reacted with it, and then it went back through the colors. The green, the middle color, is base. Let's see if we can get it to go a little slower this time. There's the acid. There's weak acid. There's neutral. And there's base again. Let's go again. There's the acid. There's weak acid. There's neutral. Neutral's green. There's base again. It's getting a little bit less basic now. Let's go with the acid again. There's the acid. There's the acid. This time, oh, there, going slower now. Weak acid, neutral. Now we're back a little bit basic again. Okay, there's acid. Acid. Oop, there goes the green to neutral. Basic. There we go. Acid again. I don't know if you noticed this before, but when I first started, it was very cloudy. It was very cloudy. And it's still cloudy, but it's getting a little more clear. I can see it. It was cloudy because I had a suspension at first. Okay? And now, now it's getting so that I'm getting most of the magnesium hydroxide, the base, canceled out by the acid. Okay, so, and there it goes back. Oh. This is taking longer than I wanted it to. Okay, and that's kind of green. It's neutral. Probably this will be the last one I can get. Okay. Now on the outside of this, there's some condensation. You know where that came from? That came from water in the air. It condensed on there and became a liquid. That's like a kind of like dew does on grass. And I don't know if you can see this now, but the solution, this has become a solution. Before it was a suspension because it was cloudy, and the magnesium hydroxide is a suspension. But now it's clear because we have a solution. Now, what's in there? Could you write an equation for what happened in there? You might be able to. Oops, it's just starting to turn again. There it goes. It goes back a little bit. It's getting back. It's very weak acid now. And it's getting ready to go. Let me make it so I finish up completely at acid. There we go. Okay, now we can write an equation for this. It's clear now that we have a solution. But magnesium hydroxide plus hydrochloric acid gives you what? Well, you should say, well, it gives you water, H2O, and magnesium chloride. Okay, you write the balanced chemical equation. And then, now is the magnesium chloride in the solution or what? And if you look here, it's clear, so that means the magnesium chloride is dissolved in the water. The magnesium hydroxide, though, is insoluble, so it makes a suspension, but now that we have magnesium chloride, it's completely clear. So that concludes our Mom to the Rescue demonstration. Well, I'm not sure I got to adequately explain last time. I guess I should make it a little bit more clear. What happened there was that the universal indicator is red in an acid, strong acid, and then as the acid becomes more dilute, it goes to orange and yellow. Green is neutral, and then blue is base, and purple is more basic. And then it's called Mom to the Rescue because milk and magnesia can come to the rescue if the acid is attacking your stomach. So like the beaker's in a way kind of like the stomach with a little excess acid, and the Mom neutralizes it and makes it more comfortable. There was one thing I forgot about the demonstration we just did, and that's the ice. The ice is important. The ice was added to slow down the reaction so the colors would last longer, because cooling a reaction slows it down. Warming a reaction generally speeds it up.